Hi folks, we're going to take a look at page 43, number 53E from the course review. So here they give us these two functions and they want us to find the domains of the composite functions f of g at x and g of f at x. Okay, so let's start with f of g at x. Okay, so if we take a look at g of x, we see that its domain has restrictions. Now that's the first function that x is being inputted into. So we have to look here, and if you look at the function square root of x minus 3, you can quickly draw a graph and see that its domain is everything greater than or equal to 3. Okay, then these outputs are being input into the function f, but the function f is a polynomial, so it has no restrictions. Okay, so right off the bat, we can just say that the domain is either in set notation, x an element of R such that x is greater than or equal to 3, or we can use interval notation, which is just inclusive of 3 to positive infinity. Okay, so either one's acceptable. Now, one thing you can always do is actually write out the final function. Okay, so here f of g of x means we're taking f at root x minus 3, and then we just input that into the function f. So that's going to be root x minus 3 plus 3 squared. Okay, and we can see from here that the only restriction is that whatever's inside the square root is going to have to be positive. Okay, so we could have made the argument both by just thinking of one function being followed by the other, or just actually write out the function and from there determine what the restrictions are. Okay, so let's take a look at g of f at x. I think this one's going to be a little bit more interesting. Okay, so if we take a look at f at x, there's no restrictions. You can put any x value into this function, but then these numbers are being input into this function here. And because it's a little more complex, I think I will go and actually input all the expressions. So here, this is g at x plus 3 squared, and now I'm inputting this into the function g. So what do we have? Square root of, instead of x, we're inputting x plus 3 squared, then minus 3, and we see that this whole expression inside the square root needs to be greater than or equal to 0. Okay, so determining the domain of this function becomes a question of solving this inequality. X plus 3 squared minus 3 needs to be greater than or equal to 0. Okay, so this is just a polynomial inequality. We already have 0 on the other side, so let's just work with the left-hand side. So I'll expand this binomial squared, so x squared plus 6x plus 9 minus 3 greater than or equal to 0, and this just becomes x squared plus 6x, plus 6 greater than or equal to 0. All right. Now, ideally, I would factor this to find the 0, so I can draw my number line and figure out where this is greater than or equal to 0. But here, this is not going to be factorable. So I'll use the quadratic formula to find the x-intercepts. So the x-intercepts here make this equal to 0. So x is going to be equal to negative b, which is negative 6, plus or minus square root of b squared, which is 36, minus 4 times a, which is 1, times c, which is 6, all over 2a. So it's 2 times 1 is 2. So here, what do we have? We have negative 6 plus or minus. So here we've got 36 minus 24. So that's 12. Okay, and just to make things a little easier or a little nicer to look at, I'll actually simplify this. So negative 6 plus or minus 12 is 4 times 3. Square root of 4 is 2. So this is 2 root 3. Okay, and here I can divide the 2 to both terms. So this just ends up being negative 3 plus or minus root 3. Okay, so if we draw a number line here, our 2 x-intercepts, so the only places where this can change sign are at negative 3 plus root 3 or positive 3 plus root 3. Clearly that's the smaller one. This should be negative 3 minus root 3. Sorry about that. And negative 3 plus root 3. Okay, and like I said, this one's clearly smaller than that one there. But because this is a quadratic with a positive leading coefficient. I know my parabola looks like this. So where is this going to be positive? Where is this whole expression be positive? When x is less than or equal to -3 minus root 3, or greater than or equal to -3 plus root 3. So that's going to be my domain. So my domain, okay, and I'll use interval notation here. I think it's a little easier. So from -infinity to -3 minus root 3, and here I'm including it because it's inside a square root. It's okay to be equal to 0. And then union, again, I'm going to include -3 plus root 3 all the way to positive infinity. Okay. So just to recap on how to find domains of composite functions. Okay, so first of all, you want to make sure you get the right order. So first you consider the first function that's receiving the inputs, okay, figure out any restrictions, and then those outputs have to be in the domain of the second one. So in this case here, the second function was a polynomial. There were no restrictions. So the only restrictions came from the first function. Here, the first function had no restrictions. The restrictions came from the fact that I had to take the square root in the second function. Okay, that's it for this one.